In this video, I'm going to show you how to conduct a one-sample t-test in SPSS. The example data correspond to the sleep study where people self-reported the amount of sleep that they get, and the sample size is equal to 10 in the first instance. And the hypothesis, which I generated based on my own hunch, is that there may or may not be a statistically significant difference between what people self-report and my expectation of 8 hours sleep on average per night. So I'm going to test the hypothesis with a one-sample t-test because I've only got one sample of data and my population value, if you will, of 8. So go into Analyze, Compare Means, One-Sample T-Test, and put your variable in the Test Variables box. And here, importantly, is the test value option. And the default is 0. That is not my null hypothesis expectation. In this study, the null hypothesis expectation is 8. So I'm going to put the number 8 there. If you click on Options, there aren't many in the way of options, just the 95% confidence interval that you can select or change. The default is 95. I encourage you to keep that if that's what you want, but you can change it if you want as well. Click Continue and click OK. And so here is the result associated with the analysis. We can see that in the first table, one sample statistics, sleep underscore N10, that's the variable, with 10 cases, and the mean is 7.31, which is numerically different from my null hypothesis expectation of 8. I don't know if it's statistically significantly different from 8 yet. I just know it's numerically different. And here's the standard deviation of these self-reported sleep scores, 1.06. So on average, people reported 7.31 hours of sleep, and there was a standard deviation of 1.06 associated with the 10 cases. Now here's the standard error of the mean, 0.335 is the standard error of the mean associated with this mean of 7.31. Now if we go down to the one sample test table, we find that most importantly, the p-value was estimated at 0.070. And because this p-value is not less than 0.05, I have failed to reject the null hypothesis that the sample mean would equal my null hypothesis expectation, which was 8. So the null hypothesis has not been rejected. I cannot declare that 7.31 is statistically significantly different from 8. And that's with a t-value of negative 2.058 and 9 degrees of freedom. And the mean difference between 7.31 and 8 is negative 0.69. So I've mentioned before that t-values close to 2 usually indicate a statistically significant effect, and that is almost always true. But when your sample size is so small, like a sample size of 10, you actually need a t-value that's even bigger than 2. But once you have sample sizes greater than 20, 30, 40, a t-value of 2, whether negative or positive, is usually going to indicate a significant effect. Now finally, here are the 95% confidence intervals associated with the one sample t-test. And this is telling me that the mean difference, this is the point estimate here, of negative 0.69, which is the difference between this mean and the test value of 8. The 95% confidence intervals associated with that mean difference is negative 1.45 rounded with an upper bound of 0.07. Now the fact that confidence intervals intersected with 0 is consistent with the p-value being greater than 0.05, because I can't declare with 95% confidence whether the difference between the mean and the test value is negative or positive. It could be larger, it could be smaller with 95% confidence. So I haven't rejected the null hypothesis with a sample size of 10. Now what if I redid this study as I do in the textbook with a sample size of 100? So let me just get those data. So the mean is going to be exactly the same and the standard deviation is going to be exactly the same. All I've done is I've increased from 10 to 100 cases. Let's check that out. Analyze, Compare Means, One Sample T-Test, 100. Change my test value to 8 and click OK. So exactly the same analysis. The mean and standard deviations are exactly the same. Standard error of the mean has dropped quite substantially from 0.335 down to 0.106. And here's the t-value, negative 0.6509, with a p-value less than 0.05. In fact, it's less than 0.001. And the 95% confidence intervals are now both on the negative side, implying that this value, the sample value, is statistically significantly smaller than my hunch of 8 hours per night, the test value. So that's the difference between increasing from 10 to 100. It decreases the standard error of the mean substantially, and the corresponding 95% confidence intervals are also smaller. The t-value is bigger. The degrees of freedom are obviously bigger because the degrees of freedom equal n minus 1. And again, importantly, the p-value is less than 0.05. So the null hypothesis has been rejected in this case. The sample mean of 7.31 may be declared to be statistically significantly smaller than the test value hunch of mine equal to 8.